Hello and welcome to isaykids. We would study grade 10 chapter chemical reactions and equations in a way that you must have not seen ever before. So, subscribe to the channel and let us know your feedback after the video too. The processes in which a substance or substances undergo a chemical change to produce new substance or substances with entire new properties are known as chemical reactions. Please note that these changes cannot be reversed by physical methods. In this super interesting chemistry chapter, we shall talk about chemical equations, types of chemical reactions, and oxidation reactions. To understand the chemical reactions, let's take cue from our daily lives. Consider the following situations of daily life and think what happens when milk is left at room temperature during summers, or when an iron tawa or pan or nail is left exposed to humid atmosphere. What happens when grapes get fermented, or when food is cooked? What happens when food gets digested in our body, or when we respire? In all these situations, the nature and identity of the initial substance have somewhat changed. Whenever a chemical change occurs, we can say that a chemical reaction has taken place. What is actually meant by chemical reaction? How do we come to know that a chemical reaction has taken place? A student performed an activity to see a chemical reaction taking place. He cleaned a magnesium ribbon about 3 to 4 centimeters long by rubbing it with sandpaper. Holding it with a pair of tongs, he burnt it using a burner and collected the ash so formed in a watch glass as shown here. Guess what did he observe? He observed that magnesium ribbon burns with a dazzling white flame and changes into white powder. This powder is magnesium oxide. It is formed due to reaction between magnesium and oxygen present in the air. Now, if I ask you, how do we know that a chemical reaction has taken place? We can say that any of the following observations helps us to determine whether a chemical reaction has taken place. For example, when there is a change in state, or there is a change in color, or there is some evolution of a gas, or finally, if there is a change in temperature. As we observe the changes around us, we can see that there is a large variety of chemical reactions taking place around us. We will study about the various types of chemical reactions and their symbolic representation in this chapter. Let's start with the chemical equations. Like we just discussed, when a magnesium ribbon is burnt in oxygen, it gets converted to magnesium oxide. The substances that undergo chemical change in the reaction, magnesium and oxygen, are the reactants. The new substance is magnesium oxide, formed during the reaction as a product. A word equation shows change of reactants to products through an arrow placed between them. The reactants are written on the left hand side with a plus sign between them. Similarly, products are written on the right hand side with a plus sign between them. The arrowhead points towards the products and shows the direction of reaction. Let's see how to write a chemical equation. Is there any other shorter way for representing chemical equations? Chemical equations can be made more concise and useful if we use chemical formula instead of words. A chemical equation represents a chemical reaction. In the example of the chemical reaction we discussed, let's replace magnesium oxygen and magnesium oxide with their respective formula, and hence the equation becomes Mg plus O2 gives MgO. Now count and compare the number of atoms of each element on the left hand side and right hand side of the arrow. Is the number of atoms of each element the same on both the sides? If yes, then the equation is balanced. If not, then the equation is unbalanced because the mass is not the same on both sides of the equation. Such a chemical equation is a skeletal chemical equation for a reaction, just like the equation for burning of magnesium in the air. Now let's see balanced chemical equations. Recall the law of conservation of mass that you studied in class 9. It says mass can neither be created nor destroyed in a chemical reaction. That is, the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. In other words, the number of atoms of each element remains the same before and after a chemical reaction. Hence, we need to balance a skeletal chemical equation. Is this chemical equation balanced? Let us learn about balancing a chemical equation. Let's do it step by step. Let's take a few zinc granules in a conical flask or a test tube and then add dilute hydrochloric acid or sulfuric acid to this. The word equation for this may be represented as zinc plus sulfuric acid gives zinc sulfate plus hydrogen. This word equation may be represented by the chemical equation Zn plus H2SO4 gives ZnSO4 plus H2. Let us examine the number of atoms of different elements on both sides of the arrow. Number of atoms of Zn in LHS as well as RHS is 1. Number of atoms of hydrogen in left hand side as well as right hand side is 2. Number of atoms of sulfur in left hand side as well as right hand side is 1. Now the number of atoms of oxygen in left hand side as well as right hand side is 4. As the number of atoms of each element is the same on both sides of the arrow, it is a balanced chemical equation. Let us try to balance a chemical equation. Fe plus H2O gives Fe3O4 plus H2. Step 1. To balance a chemical equation, first draw boxes around each formula. Do not change anything inside the boxes while balancing the equation. Step 2. List the number of atoms of different elements present in the unbalanced equation. Fe here is 01 and 03 respectively. Hydrogen is 2 and 2. And oxygen is 1 and 4. Now the next step is start balancing with the compound that contains the maximum number of atoms. It may be a reactant or a product. In that particular compound, select the element which has the maximum number of atoms. Using these criteria, we select Fe3O4 and the element oxygen in it. There are 4 oxygen atoms on the right hand side and only 1 on the left hand side. Now, to equalize the number of atoms, it must be remembered that we cannot alter the formula of the compounds or elements involved in the reactions. To balance oxygen atoms, we can put coefficient as 4 as 4H2O and not H2O4 or H2O whole 4. Now the partly balanced equation becomes Fe plus 4H2O gives Fe3O4 plus H2. Next step is iron and hydrogen atoms are still not balanced. So, pick any of these elements to proceed further. Let us balance hydrogen atoms in the partly balanced equation. To equalize the number of hydrogen atoms, make the number of molecules of hydrogen as 4 on the right hand side. Next step is examine the given equation and pick up the third element which is not balanced. You find that only one element is left to be balanced, which is iron. To equalize iron, we take 3 atoms of iron on the left hand side. Finally, to check the correctness of the balance equation, we count atoms of each element on both sides of the equation. The number of atoms on both sides are now equal. This equation is now balanced. This method of balancing chemical equations is called hit and trial method, as we make trials to balance the equation by using the smallest whole number coefficient. Next step is to make a chemical equation more informative. The physical states of the reactants and products are mentioned along with their chemical formula. The gaseous, liquid, aqueous, and solid states of reactants and products are represented by the notations G, L, AQ, and S respectively. The word aqueous is written if the reactant or product is present as a solution in water. The balanced equation becomes 3FeS plus 4H2O G gives Fe3O4S plus 4H2G. Note that the symbol G is used with water to indicate that in this reaction, water is used in the form of steam. Usually, physical states are not included in a chemical equation unless it is necessary to specify them. Sometimes the reaction conditions, such as temperature, pressure, catalyst, etc., are for the reaction that are indicated above and or below the arrow in the equation. For example, 340 atmospheric pressure. The equation of photosynthesis involving sunlight and chlorophyll. Interesting, isn't it? Now, time for some questions. Why should a magnesium ribbon be cleaned before burning in air? Any guesses? Well, it is because magnesium is a reactive metal. It combines with oxygen in air to form a layer of magnesium oxide on its surface. Hence, it should be cleaned with a sandpaper before burning to remove the oxide layer formed on its surface. Next question. Before moving on to the next question, I would request you guys to hit the like button and subscribe to the channel. Now the next question is to write the balanced equation for the following chemical reactions. Hydrogen plus chlorine gives hydrogen chloride. Barium chloride plus aluminum sulfate gives barium sulfate plus aluminum chloride. And sodium plus water gives sodium hydroxide plus hydrogen. Let's see again what a balanced chemical equation is. It is the representation of a chemical reaction in which the number of atoms of each element is the same on both the reactant and product sides. In the first reaction, hydrogen reacts with chlorine to form hydrogen chloride. The chemical reaction can be represented as H2 plus Cl2 gives HCl. But whereas there are two atoms of hydrogen and chlorine each on left hand side, there are only one each on the right hand side. To balance it out, it would be H2 plus Cl2 gives 2HCl. It is now a balanced equation. Moving on to the next one. Barium chloride plus aluminum sulfate gives barium sulfate plus aluminum chloride. Now the skeletal reaction is barium chloride plus aluminum sulfate, which is BaCl2 plus Al2SO4 thrice gives BaSO4 plus AlCl3. Aluminium sulfate compound, we will take it first because it has more number of atoms, which is 2 atoms of aluminium are present on the reactant side and 1 atom on the product side. To balance aluminium, take the coefficient of AlCl3 on product side as 2. Now consider the set SO4 instead of SNO separately because it is present in reactant and product side in the same form. There are 3 sets of SO4 on the reactant side and 1 set on the product side. To balance this, take the coefficient of BaSO4 as 3. So far, so good. Now consider barium. There are 3 atoms on product side and 1 atom on reactant side. To balance it, take the coefficient of BaCl2 as 3. The chlorine atoms are also balanced, 6 on each side. Thus, this is the balanced equation. Let's do the next one now. Sodium plus water gives sodium hydroxide plus hydrogen. And the chemical equation for this reaction is Na plus H2O gives NaOH plus H2. Now let's balance it. On the left hand side as well as on the right hand side, only one sodium atom and oxygen atom is present, which is correct. But on the left hand side or on the reactant side, we can say 2 atoms of hydrogen are present and 3 on the right hand side or on the product side. So the balanced chemical equation for this reaction is 2Na plus 2H2O gives 2NaOH plus H2. Fun, interesting, right? Let's move on to the next question. Write a balanced chemical equation with state symbols for the following reactions. Solutions of barium chloride and sodium sulfate in water react to give insoluble barium sulfate and the solution of sodium chloride. Sodium hydroxide solution in water reacts with hydrochloric acid solution to produce sodium chloride solution and water. When sodium hydroxide, a base in water, reacts with an acid of hydrochloric acid, it gives sodium chloride and water. The reaction is NaOH plus HCl gives NaCl plus H2O. As we can see, number of sodium atoms are 1 on each side. Oxygen is also 1. Hydrogen is 1 plus 1, that is 2 on the left hand side and also 2 on the right hand side. And chlorine is 1 on each side. Hence, the equation is balanced. Thus, when sodium hydroxide and hydrochloric acid combine, sodium chloride salt and water are formed. It's a neutralization reaction when an acid combines with a base to produce salt and water. Moving on to the next one. Solutions of barium chloride and sodium sulfate in water react to give insoluble barium sulfate and the solution of sodium chloride. The equation is BaCl2 plus Na2SO4 gives BaSO4 plus 2 NaCl. Note that the reaction does not happen if both barium chloride and sodium sulfate are solid. This is an example of double displacement reaction. In case you're liking the video, please hit the like button. During a chemical reaction, atoms of one element do not change into those of another element, nor do atoms disappear from mixture or appear from elsewhere. Actually, chemical reactions involve the breaking and making of bonds between atoms to produce new substances. Next is the combination reaction. To understand it, let's perform an activity. Take a small amount of calcium oxide or quicklime and put it in a beaker. Slowly add water to this. Touch the beaker. Do you feel any change in temperature? Let's see what happens here. Calcium oxide reacts vigorously with water to produce slaked lime, which is calcium hydroxide, releasing a large amount of heat. It can be represented as CaO plus H2O gives CaOH twice plus heat. In this reaction, calcium oxide and water combine to form a single product, calcium hydroxide. Such a reaction in which a single product is formed from two or more reactants is known as a combination reaction. A solution of slaked lime produced by the reaction that we just discussed is used for whitewashing walls. Calcium hydroxide reacts slowly with the carbon dioxide in air to form a thin layer of calcium carbonate on the walls. Calcium carbonate is formed after 2 to 3 days of whitewashing and gives a shiny finish to the walls. The chemical equation would be CaOH twice plus CO2 gives CaCO3 plus H2O. It is interesting to note that the chemical formula for marble is also CaCO3. Let us discuss some more examples of combination reactions. First is burning of coal. Any guesses what happens here? Come on, take a guess. Okay, here we go. Carbon plus oxygen gives carbon dioxide. Next is formation of water from H2 and O2. It would be 2H2 plus O2 gives 2H2O. Okay, now do you know what are those reactions called in which heat is released along with the formation of products? Well, these are called exothermic chemical reactions. In Greek, exo means outside and thermi means heat. For example, burning of natural gas. CH4 plus 2O2 gives CO2 plus 2H2O. Do you know that respiration is an exothermic process? We all know that we need energy to stay alive. We get this energy from the food we eat. During digestion, food is broken down into simpler substances. For example, rice, potatoes, and bread contain carbohydrates. These carbohydrates are broken down to form glucose. This glucose combines with oxygen in the cells of our body and provides energy. The special name of this reaction is respiration. Let's see the chemical reaction happening here. C6H12O6, which is glucose, plus 6O2 gives 6CO2, which is carbon dioxide, and 6H2O, which is water plus energy. The decomposition of vegetable matter into compost is also an example of an exothermic reaction. Hope this is clear. If yes, let's move on to the next type of chemical reaction. It is decomposition reaction. Somebody performed an activity to understand the decomposition reaction. Let's see that activity. Take about 2 grams of ferrous sulfate crystals in a dry boiling tube. Note the color of the ferrous sulfate crystals. Heat the boiling tube over the flame of a burner or spirit lamp as shown here. Observe the color of the crystals after heating. We noticed that the green color of the ferrous sulfate crystals had changed. We could also smell the characteristic odor of burning sulfur. The chemical equation is 2FeSO4 gives Fe2O3 plus SO2 plus SO3. A single reactant breaks down to give simpler products. This is a decomposition reaction. Ferrous sulfate crystals, which is FeSO4, lose water when heated and the color of the crystals change. It then decomposes into ferric oxide, which is Fe2O3, sulfur dioxide, which is SO2, and SO3, which is sulfur dioxide. Ferric oxide is a solid, while SO2 and SO3 are gases. Let's see one more example. Decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries. CaCO3 gives CaO plus CO2 on heating. Calcium oxide is called lime or quicklime. It has many uses. One is in the manufacture of cement. When a decomposition reaction is carried out by heating, it is called thermal decomposition. Let's see one more example of thermal decomposition via an activity. Take about 2 gram lead nitrate powder in a boiling tube. Hold the boiling tube with a pair of tongs and heat it over a flame. You will observe the emission of brown fumes. These fumes are of nitrous dioxide. The reaction that takes place is 2PbNO3 twice gives 2PbO plus 4NO2 plus O2. Let's see some more decomposition reactions. If we take some silver chloride, we would notice that its color is white. Now, if we place it in sunlight for some time, the color of the silver chloride changes to grey. This is due to the decomposition of silver chloride into silver and chlorine by light. The reaction is 2AgCl gives 2Ag plus Cl2. Silver bromide also behaves in the same way. 2AgBr in sunlight gives 2Ag plus Br2. These reactions are used in black and white photography. What form of energy is causing these decomposition reactions? We have seen that the decomposition reaction require energy either in the form of heat, light, or electricity for breaking down the reactants. Reactions in which energy is absorbed are known as endothermic reactions. Let's perform one more activity. Take about 2 gram barium hydroxide in a test tube. Add 1 gram of ammonium chloride and mix with the help of a glass rod. Now, if you touch the bottom of the test tube with your palm, you would feel that it is cold. It is due to the absorption of heat from the environment. Hence, it is an endothermic decomposition reaction. Let's see one more decomposition reaction. Take a plastic mug. Drill 2 holes at its base and fit rubber stoppers in these holes as shown here. Insert carbon electrodes in these rubber stoppers. Connect these electrodes to a 6-volt battery. Fill the mug with water such that the electrodes are immersed. Add a few drops of dilute sulfuric acid to the water. Take 2 test tubes filled with water and invert them over the 2 carbon electrodes. Switch on the current and leave the apparatus undisturbed for some time. You will observe the formation of bubbles at both the electrodes. These bubbles displace water in the test tubes. What do you think? Is the volume of the gas collected the same in both the test tubes? Once the test tubes are filled with the respective gases, remove them carefully. Test these gases one by one by bringing a burning candle close to the mouth of the test tubes. Be cautious that this step might be performed carefully by the teacher. Now, what do you think happened in each case? Which gas is present in each test tube? Well, we know that water contains 2 parts of hydrogen and 1 part oxygen. Therefore, during the electrolysis of water, the amount of hydrogen gas collected in one of the test tube is double than that of the oxygen produced and collected in the other test tube. Hence, this is the equation for the decomposition reaction of water. 2H2O gives 2H2 plus O2. If you're liking the video, do hit the like button, share it with your friends and family, and subscribe to the channel. Also press the notification bell for future updates. Next is the displacement reaction. To understand it, let's perform an activity first. Take 3 iron nails and clean them by rubbing with sandpaper. Take 2 test tubes marked as A and B. In each test tube, take about 10 ml copper sulfate solution. Tie 2 iron nails with a thread and immerse them carefully in this copper sulfate solution in test tube B for about 20 minutes. Keep one iron nail aside for comparison. After 20 minutes, take out the iron nails from the copper sulfate solution. Compare the intensity of the blue color of copper sulfate solutions in test tubes A and B. Also, compare the color of the iron nails dipped in the copper sulfate solution with the one kept aside. Now the question is, why does the iron nail become brownish in color and the blue color of the copper sulfate solution fades? This is because iron nail is Fe and blue copper sulfate solution is CuSO4. When nail is kept in it, Fe being more reactive than copper, it displaces copper from copper sulfate and forms ferrous sulfate, which is greenish blue. And the copper displaces deposits around nails, giving it color of reddish brown. The following chemical reaction takes place in this activity. Fe plus CuSO4 gives FeSO4 plus Cu. In this reaction, iron has displaced or removed another element, copper, from copper sulfate solution. This reaction is known as displacement reaction. Other examples of displacement reactions are zinc plus copper sulfate giving zinc sulfate plus copper, lead plus copper chloride gives lead chloride plus copper. Zinc and lead are more reactive elements than copper. They displace copper from its compounds. Next is the double displacement reaction. Take about 3 ml of sodium sulfate solution in a test tube. In another test tube, take about 3 ml of barium chloride solution. Mix the two solutions. You will observe that a white substance which is insoluble in water is formed. This insoluble substance formed is known as a precipitate. Any reaction that produces a precipitate can be called a precipitation reaction. For example, in the reaction of sodium sulfate with barium chloride, we get barium sulfate and sodium chloride. What causes this? The white precipitate of barium sulfate is formed by the reaction of SO4 and Ba. The other product formed is sodium chloride, which remains in the solution. Such reactions in which there is an exchange of ions between the reactants are called double displacement reactions. Let's do one more activity. Take lead nitrate solution in a test tube. Add potassium iodide solution to this. What do you observe? You would observe that a precipitate is formed. Now, what is the color of the precipitate formed? You would find that the color of the precipitate is yellow. Now, can you name the compound precipitated? The name of the compound formed as a precipitate is lead iodide, that is PbI2. If we were to write the balanced chemical equation for this reaction, it would be PbNO3 twice plus 2Ki gives PbI2 plus 2KNO3. What do you think? Is this also a double displacement reaction? Let us know in the comment section below. Next is the oxidation and reduction. The surface of copper powder becomes coated with black copper oxide. Why has this black substance formed? This is because oxygen is added to copper and copper oxide is formed. The chemical equation involved here is 2Cu plus O2 gives 2CuO. Now, can we reverse this reaction? Let's try. If hydrogen gas is passed over this heated material, which is copper oxide, the black coating on the surface turns brown as the reverse reaction takes place and copper is obtained. That is, CuO plus H2 gives Cu plus H2O upon heating. If a substance gains oxygen during a reaction, it is said to be oxidized. If a substance loses oxygen during a reaction, it is said to be reduced. During this reaction, the copper oxide is losing oxygen and is being reduced. The hydrogen is gaining oxygen and is being oxidized. In other words, one reactant gets oxidized while the other gets reduced during a reaction. Such reactions are called oxidation-reduction reactions or redox reactions. Some other examples of redox reactions are zinc oxide plus carbon gives zinc plus carbon monoxide. In this reaction, carbon is oxidized to CO and zinc oxide is reduced to zinc. Let's see one more example. MnO2 plus 4HCl gives MnCl2 plus 2H2O plus chlorine, Cl2. In this reaction, HCl is oxidized to chlorine, whereas MnO2 is reduced to manganese chloride. Hence, we can say that if a substance gains oxygen or loses hydrogen during a reaction, it is oxidized. If a substance loses oxygen or gains hydrogen during a reaction, it is reduced. Do you remember the activity where a magnesium ribbon burns with a dazzling flame in air and changes into white substance, magnesium oxide? Is magnesium being oxidized or reduced in this reaction? When a magnesium ribbon burns to form a white ash, magnesium metal is oxidized in this reaction because it combined with oxygen to form magnesium oxide. Liking this video? Like, share and subscribe and help us reach more and more students. Have you observed the effects of oxidation reactions in everyday life? The first is corrosion. You must have observed that iron articles are shiny when new, but get coated with a reddish brown powder when left for some time. This process is commonly known as rusting of iron. Some other metals also get tarnished in this manner. Have you noticed the color of the coating formed on copper or on silver? When a metal is attacked by substances around it, such as moisture, acids, etc., it is said to corrode, and this process is called corrosion. The black coating on silver and the green coating on copper are other examples of corrosion. Corrosion causes damage to car bodies, bridges, iron railings, ships, and to all objects made of metals, especially those of iron. Corrosion of iron is a serious problem. Every year, an enormous amount of money is spent to replace damaged iron. We would talk more about corrosion in chapter 3. Rancidity. Have you ever tasted or smelled the food that has been left for a long time? When fats and oils are oxidized, they become rancid and their smell and taste changes. Usually substances which prevent oxidation, that is antioxidants, are added to foods containing fats and oils. Keeping food in airtight containers helps to slow down oxidation. Do you know that chips manufacturers usually flush bags of chips with gas such as nitrogen to prevent the chips from getting oxidized? With this, we complete this chapter. See you next time with the next chapter. Meanwhile, to explore our other wonderful videos, we have a wide range of them because the world is so big and the curious kid in us wants to know it all. Bye bye for now. Make healthier choices, be kind, and keep learning. Lots of love, I say kids.